Good morning, my Connors Koalas. Today is Connors School Spirit Day. I hope everybody's wearing all their Connors School swag. Send all your pictures and videos to Mr. Sorfine, and he's going to make a whole school-wide video that's going to be sent to everybody at our school. All right, who is ready for our flag salute? You ready? Here we go. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All right, I have received more requests for science experiments. So we're gonna go to my home kitchen lab and we're gonna do an experiment. You ready? Here we go. Hello, my Connors Koalas. So I have received numerous requests for experiments. So I'm gonna do an at-home experiment with hopefully materials that you have at home. Okay, so what we're gonna do is we are going to make a milk and food coloring art project that really works because it's science, because of the science behind it. So you're gonna take some milk, whole milk is preferable, and you're gonna pour it into a plate, just enough to cover the bottom of the plate. Then what you're gonna do is you're gonna get food coloring, if you have food coloring in your house, and you're gonna put food coloring in 4 corners of the dish. So I did yellow. Now I'm going to do red, green, and blue. Okay, food coloring is water soluble, which means it's polar, and it mixes with water. Because remember, we learned that polar molecules stick together. Milk has fat in it, so all lipids are nonpolar. And nonpolar things stick together with each other, and polar things stick together with each other. But nonpolar and polar don't mix. Like, have you ever tried to wash a greasy dish with just water? It doesn't work, right? Because polar and nonpolar don't mix. But if you have soap, I have some soap in here. Soap is special because soap has a polar end of the molecule and it has a non-polar end of the molecule. So one part of soap mixes with water and one part of soap mixes with the grease, with the fat, and that's how it joins together. So let's look at the plate. I have milk and I have the food coloring that's on top of it. I'm gonna take soap, which is on my Q-tip. Come closer, come see it. This is where the magic occurs. Are you ready? There's soap on the bottom of my Q-tip. I'm gonna take it and I'm gonna dip it. Watch this, I'm gonna go right into the blue. You ready? 1, 2, 3. Boom. 1, 2, 3 into the green. 1, 2, 3 into the red. 1, 2, 3 into the yellow. And then what you could do is you could take your Q-tip with your soap, you can move it around, but if you look naturally, all the food coloring is gonna start to move and get in with the milk and move in every direction. It kind of seems like it's alive, but it actually really is the molecules breaking apart and joining with each other. And then you could just make some beautiful art. You can bring it across, make a circle, make a swirl, make different patterns. And again, it's all because of the soap joining with both the fat and the milk, the fat for the milk and the food coloring, which is water soluble. So polar and non-polar joining. And then look at this. It looks like a beautiful piece of art. I think Mrs. Musella would be impressed. All right, and it's all because of the science behind it. Have a great day, my Connors Koalas. Try this at home.